10.6, the motion of charged particles in electric fields. So when there is charge moving in electric fields, it experiences force. You know that the force equal to ma, acceleration is the force divided by m. This force is electric force. We can use the conservation of the energy. Say potential energy plus kinetic is equal to potential energy plus kinetic. Here is after they interact. Let's say we have particles, they want to interact, and here is before they interact. Looking at this question, so figure 3 shows two small conducting spheres placed on the top of insulating pucks. One puck is anchored to the surface while the other are allowed to move freely on the air table. The mass of the sphere and puck together is 0.15 kilograms, and the charge on each sphere is 3 × 10⁻⁻⁶ and 5 × 10⁻⁻⁹. The two spheres are initially 0.25 meters apart. How fast will the sphere be moving? Then they are 0.65 meters apart. Okay, so here is not moving. This one is freely to move. Before, both velocities are 0 before they interact. And there is a potential between them, right? The potential that this will have on the other one. Okay. Also, after they interact, so the distance of that, so these poles are positive. It will move to the left. When they got to the distance of 0.65, this has a velocity and it has a potential. Basically, E potential plus EK before, so EK is 0, but there is a potential, is equal to P, E prime potential plus E of K. Just one of the spheres has kinetic energy. It's going to be half mv2 prime. That's going to be the potential, which is K, Q, Q1, Q2, R2, R, and here's K, Q1, Q2, R. So these R1 and R2 are, here is R prime. And here is half mv2. So we can solve for QV. We have R, both of the R's, we have K, we have charge Q1 and Q2, and we have mass. So we can rearrange it for velocity. Okay, so here what they did, right? And, they rearranged for the velocity, and that is the velocity 0.07 meters per second. And let me just erase this. Now we know the force electric, when you have a particle in electric field, the force it feels is Q multiplied by electric. And also we know acceleration is force, electric force divided by mass. And the work done, we have proved that is difference in potential difference multiplied by Q. When it's moving from one place to another place with different potential, with different voltage, the work will be delta V multiplied by Q. Okay, looking at this question, the cathode in typical cathode ray tube found in a computer terminal or an oscilloscope is heated, which makes electrons have leave the cathode. They are then attracted toward the positively charged anode. The first anode has only a small potential rise, while the second is a large potential with respect to cathode. If the potential difference is given to be 2 × 10⁴, find the final speed of electron. So we have an initial speed to be 0. You want to find a final. You know, delta V is equal to 2 × 10⁴. And we have mass of the electron. We have a charge of the electron. You want to find a final speed. Knowing the work done is equal to change in kinetic energy, right? The work done is Q delta V, and change in kinetic energy is half mv2 minus initial half mv2. Because initial kinetic energy is 0, you don't see that. We can rearrange it for velocity here. So m to the other side, 2 to the other side, square root both sides, and the velocity. Knowing the Q delta V and m, you can find the velocity, which is 8.4 × 10⁷ meters per second. Here you can do question number 1, 2, 3 for practice. Here is another question. An electron is fired horizontally at 2.5 with 10⁶ meters per second between two horizontal parallel plates, 7.5 centimeter long. So from here to here is that. The magnitude of electric field is 130 Newton Coulomb. Electric field is given. The plate separation is great enough to allow electron to escape. So this separation is good enough for that to just escape. Edge effect and gravitation are negligible. Find the velocity of electrons. So edge is negligible means it's just uniform everywhere. There's electric field. So we have initial velocity, which was given here. Charge we have, the length is we have it. We want to find velocity of electrons that is escaping. When you said velocity, we're looking for magnitude and direction. We need to find the force first and the acceleration. The only force acting on an electron is, so this electron is attracted to the positive field, is upward. It's like a projectile motion. The path is taking is like that. Maybe I just make it better here for you. If I just put it upside down, if this is negative and this is positive, and this electron is just downward force, it's just a projectile motion. It's like that. There's the electron, right? So the downward force is force of electric, F of E, is equal to ma. Acceleration is F of E divided by m. So instead of F of E, we know the equation when you have two plates. The electric force is going to be Q multiplied by E, right? This is going to be Q multiplied by electric field, ma. You can rearrange for acceleration. It's going to be EQ divided by the mass of the electron. You can find the acceleration. So finding the acceleration, this is the acceleration in y direction. The initial velocity in y direction is 0, right? The initial in y direction is 0. We have v in x direction. V in x direction is always constant and is given to us. It is given to be 2.5 10⁶ meters per second. Also, we have the length of this, which is equal to 7.5 10⁻². We can find time here using the velocity is delta d over t. So here you can find the time. Make sure in x direction you have constant velocity motion. The only equation you have is v in x direction is delta d over time. So you can choose for time. Then you got the time to be 3 10 power negative 8. So you have time here. We got an acceleration in y direction, be 2.3 10 power 13 meter per second. So we have 3 things. We can find the fourth one, which is v final in y direction, right? Using the proper equation. The equation we can use is v2 minus equal to v1 equal to 8 plus at. v1 in y direction is 0. A we have time, we have, this is a v final. So v final in y direction, we have v final in x direction. Since the x direction is a constant velocity, this is your v final in x direction. So we need to put it together using the Pythagorean theorem. Here they missed power 2 here. So velocity in x direction, power 2 plus velocity in y direction, power 2. Square root give you the final velocity. Now you need to find the theta. Theta is tan inverse of y component of velocity divided by x component of the velocity that you have. You will find the angle as well. Let me erase everything here. And that would be the answer. 2.6 10 power 6, right? 15 degree up from the horizon.